Hello, everyone. Welcome back. Today, we're going to be talking about solving quadratic equations using the quadratic formula. As we know, there are other ways to solve, like factoring. However, factoring does not always work, nor is it always the most convenient method, even at times when it does work. And there can be a couple different reasons why factoring doesn't always work, but the main one is that sometimes there just aren't any. Sometimes there just aren't any solutions at all, and that makes it impossible to factor. It can also be the case that factoring by inspection is going to be ineffective or very difficult because the sometimes the zeros are irrational numbers or even just other fractions and decimals that wouldn't really be easy to do by inspection. Quadratic formula, on the other hand, is a very good, strong method for solving quadratics because it does not fail, right? This is basically a direct solve. If we plug in A, B, and C and then solve, we will end up with the solution. Or in the event that b squared minus 4ac is less than 0, we'll find out that there are no solutions, or at least no real solutions anyway. And since this is Algebra 1, we're not going to be talking about complex solutions here. However, if you would like to learn more about complex solutions, you can move to Algebra 2 as it's covered in that curriculum. All right, very good. Okay, let's move over here to this first example. So again, let's remind ourselves what we mean by A, B, and C. So this is based on the fact that the general standard form for quadratics is ax squared plus bx plus c. Okay, so what are A, B, and C in this case? Well, A is equal to 5, B is equal to 6, and C is equal to 1, right? Because A just means what's our leading coefficient, B is just the coefficient for x, and C is the constant. So now I need to plug in these values into the equation above to figure it out. So negative b, which is going to be negative 6, plus or minus the square root of 6 squared, minus 4 times 5 times 1, all over 2 times 5. So that's going to be negative 6 plus or minus the square root of 36 minus 20 over 10, which is going to be negative 6 plus or minus root 16 over 10, which is going to be negative 6 plus or minus 4 over 10. And so now this is where the equation kind of splits up a little bit. We need to do negative 6 minus 4 over 10, and then also negative 6 plus 4 over 10. So in this case, we're going to get negative 10 over 10, which is negative 1. And then for this case here, for example 2, we are going to end up with negative 2 over 10, which is negative 1/5. So therefore, the two solutions are negative 1 and negative 1/5. So those are our answers for this equation. X equals to negative 1 and x equals to negative 1/5. And so there we go. So this one's a great example of something that would have been challenging to factor with inspection, because would we really have guessed that one of the zeros was going to be negative 1/5? Probably not. That may have been a challenging thing to figure out, right? Okay, let's try this next example. So for this next example here, first I'm going to identify A, B, and C. So A is equal to 2, B is equal to 3, and C is equal to negative 5. Now, just as a reminder for what the equation was, it was negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be, in this case, x equals negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 5 all over 2 times 2, which is equal to negative 3 plus or minus 9 plus, negative 4 times 2 times negative 5 is going to be positive 40 over 4. That's going to give us negative 3 plus or minus root 49 over 4, which is going to give us negative 3 plus or minus 7 over 4. And let's see, that's going to be negative 3 minus 7 over 4, and then also negative 3 plus 7 over 4. So this is going to be negative 10 over 4, which is the same as negative 5 over 2. And the second one is going to be 4 over 4, which is 1. And so these are our two final solutions there for this one. All right, let's try a third and fourth example. Okay. So for this one here, we have that A is equal to 1, B is equal to negative 4, and C is equal to 4. So here we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's going to be negative 4 plus or minus the square root of negative 4 squared minus 4ac all over 2a, which is equal to 4 plus or minus square root of 0 over 2. And of course, whether we do plus 0 or minus 0, that's still going to be 0, right? And so therefore, we just have one solution, which is x is equal to 2. So this one we actually could have factored. However, as you can see, yeah, it took a little bit of extra time with the quadratic formula. However, the quadratic formula works for all equations. Factoring only works sometimes when it comes to solving quadratics. All right, and let's do one last one here. In this case, A is equal to 3, B is equal to negative 2, and C is equal to 7. So x is equal to negative b, so negative 2, plus or minus the square root of b squared minus 4ac all over 2a, which is equal to 2 plus or minus square root of 4 minus, 4 times 3 times 7 is 84 all over 6, which is equal to 2 plus or minus root of negative 80 over 6. Now, as we know, we cannot have a negative in our square root, right? That is not possible. I'm just realizing I'm covering this. There we go. Okay, we can't have a negative in our square root. We could write this in terms of complex solutions. However, complex solutions generally aren't a part of Algebra 1. So for this example, we could stop here and we could say there are no solutions. There are no values for x that would work here. At least there are no real ones. And if we were to graph this, we would actually see that the graph would not hit the x-axis at all because there are no solutions. There are no x-intercepts here. And so this one certainly would be one we wouldn't be able to factor even if we tried, or even if we had like a computerized way to factor this where the computer would be able to figure it out even if there's fractions or decimals or something like that. They still wouldn't be able to do it, not without complex solutions anyways. All right, well, that's all for this one. We hope to see you for the next one, and feel free to leave any questions you might have in the comments below.